Alright, so here we are with our Chapter 1, Section 2. We're going to talk about solving equations by adding and subtracting. So, as we're working through this, remember that you are going to, for your objectives, again, try to do this adding or subtracting solving. Alright. We're also trying to do the Cornell-style notes, so go ahead and put your title at the top, the date today that you are watching this video, and then your objective, which would be your kind of main idea. In the notes section, we're going to first talk about an equation. And so an equation is a mathematical statement that two expressions are equal. So what we've been doing up until now is expressions, and expressions are not equations because expressions do not have an equal, but an equation does. Okay, so they of course sound exactly the same, but the idea is that one of them has an equal or an equation. So other than that, the solution of an equation is a value of the variable that makes the equation true. So most of the time you end up with something like x equals and then a number like 2. So you're not just going to end up like with expressions where you just have a number, you're going to have a variable equal to that number. To find solutions, you need to isolate the variable, so we're going to talk a lot about isolating the variable or getting the variable alone. And then we're also going to be talking about, conversely, what is preventing, for instance, that variable from being alone on the side of the equals. So a variable is isolated when it appears by itself on one side of an equation and not at all on the other side. So if you look at what we're talking about here, we've got an x on one side of this equation and then a 2 on the other. So once it's all by itself, we have now fully isolated and we have an answer. All right. So first thing that we're looking at here is isolating a variable by using inverse operations are going to undo those operations that are happening. So for instance, if you're looking at an equation and you see addition, you're going to end up doing subtraction in order to undo that. Subtraction, if you see it, you undo subtraction with addition. Okay, so if you see this operation, then you need to do the inverse operation. It's kind of like up and down inverse operations or squared and square root inverse. The idea is that one will kind of cancel the other. In this phrase here, it is saying an equation is like a balanced scale. So to keep the balance, you need to perform the same operation on both sides. So if you decide to cancel something by adding, all right, you're going to have to add to the other side as well. Otherwise, your scale's not balanced. So taking a look at what we are seeing, a lot of times when we're solving, the best way to figure out how to solve is to end up kind of dividing your equation at the equal sign. Some people call this train tracks or whatever it happens to be, but the idea is that you're going to split the equation into the two equal sides. So y minus x, whatever it happens to be, will end up exactly equal to 24. Now, guessing and checking is completely likely in these situations, but once we get to the ones that are a little bit more complex, guessing will no longer work and then you're stuck. So instead, we're going to actually look at how we do it in each step so that once we get to a 10-step problem, it won't be that difficult. So if we look at what's happening, usually I will talk about where the variable is. So over here we have the y variable, and then we're going to ask ourselves what is being done to it. So if you look at the y, what's being done is subtracting 8. And since we're solving by subtracting or adding, I'm actually going to add an 8 to both sides. And in adding an 8 to both sides, meaning we want it to be equal, I will now end up with a balanced equation, and y will end up being by itself. Officially, what we do have is y minus 8 plus 8, and that is going to equal 24 plus 8, if you think of it as one line of text. But of course, if you're going to take something and subtract 8 and add 8, they end up just making 0. So you could take the time and write y plus 0 over here and the fact that it equals something, but we don't usually say plus 0. So we're just going to say y, which is left over on the left side, and the fact that 24 plus 8 is 32. So we now know that if we went to the original equation and put a 32 in for our y, we would get our answer. And in fact, that's what we're going to do over here when it says check your answer. So what you do when you check your answer is you need to rewrite the original equation. So if you rewrite the original equation, we have y minus 8 equals 24. The next thing that you would need to do is replace the variable with the answer. And so in this case we got 32. But then we still have minus 8 equals 24. And then you would solve to see if they're the same. And so we would actually take 32 minus 8 and realize that it's 24, which of course is equal to the 24 that we had. And now officially that is where our check would come in. All right, so each of the problems that you have on your assignment that are going to be like this, you are going to want to show me what is the opposite operation by writing it like I did right here. You will also need to, of course, express what the answer is. A lot of times with an answer, we'll end up boxing or ovaling it or something. And then you are actually going to have to check. So there will be a space on your worksheet for a check. So rewrite the original, plug in the variable that you solved for, and then actually see if 32 minus 8 is 24. All right. On this next one here, we have decimals, but it's the same idea. You'll also notice that our variable is on the right side now instead of the left, and also instead of being a y, it's a t. So we've talked about that in the first bit of this chapter, but it's okay if you have a t or an x or a y, whatever the variable letter is, that's fine. Usually we avoid things like O, because it looks like a 0, and S, those end up looking like 5s. But either way, we are going to solve this. So we're going to realize that we have equal sides of this equation. So we have a 4.2 on the left and a t plus 1.8 on the right. And now we're going to isolate that t, or that variable, by realizing what's happening to it. And to it, it's being added a 1.8. So what's the opposite of adding something? We're going to subtract it. So we're subtracting 1.8 from both sides. And I'm not going to write the phrase that I did on the last page, because hopefully we can see that we're just going to take 4.2 and subtract 1.8, and we're going to get 2.2, I believe, 2.4. So we have 2.4 as the result of 4.2 minus 1.8. And then over here, if we take our 1.8 and our negative 1.8, they cancel, or it's actually 0. And that's supposed to be an equal sign, but that was done badly. And so in that case, we end up with just t all by itself. These will all be one-step equations, so just note that you're only going to have to add or subtract one thing, and then you'll be done. And of course, later on, we'll go to multiple-step equations. So then we go over here and do our check. And again, in order to check, you rewrite the original equation exactly how it is. Then fill in the variable that we got. So still have 4.2, but now t is actually 2.4. And we're going to check if plus 1.8 actually equals that. So that's when you might get out a calculator, especially if there are negatives or just decimals or fractions involved. But the idea is that you'd be able to look at that and add them together. So 4.2, realize they're the same value, and get a check, and maybe even make it a check smiley face. Super. All right, this last example that we have goes over a word problem. So over 20 years, the population of a town decreased by 275 people to a population of 850. We need to write and solve an equation to find the original population. So interesting part about this, of course, is that they're using this number 20, which actually has nothing to do with the problem. So the idea is that the population of a town decreased. So this population is going to decrease by 275 people, and it's going to become a population of 850. So how do I get this phrase from what's above? And again, that's what our first part of chapter 1 was all about. The population of a town is going to be represented by P. Decreased is going to be represented by the subtraction sign, or decreased by. We also have 275, which of course is in there. And then 2 in this case is actually our equals sign to a population of 850. So again, as you break this down into its words to its expression or equation here, you go through the population of a town represents P, decreased by is subtraction, 275, and then becomes or goes to a population, so equals 850. So we've got our equation, and now we can go through and solve it. And so in order to find the original population, I'm going to add 275. I choose to add 275 and not 850 because I'm looking for the variable itself and what's happening to it. So the variable is on the left here, and it's being subtracted by 275, so I'll add a 275, and now I'm left with the population, which initially was 850 plus 275, so 1,025. Wait, 125. 1,125. All right. So, and I guess it's a word problem, so people. Okay. So those are our two solutions. Again, we've got our equation, and then we've also got our answer. In this set of notes, again, it's always good to see what it was that you were supposed to accomplish. So hopefully we understand how to solve one-step equations in one variable by using addition or subtraction. So remember that the idea is that you look at what's happening to the variable itself, in this case subtracting, and so you'd solve by adding. In our next example, we said that we have adding, and so we're going to solve by subtracting or undoing what's happening. And again, many of these you can do in your head, but we're hoping that you take the time, I'm hoping that you take the time to write down the equation, write down your opposite step, so that you get into that habit when we get to a multi-step equation. All right, so you can go ahead and be done with our notes, and tomorrow we'll have an assignment reflecting this.